So today's session is about data loss and how to manage risks related to it. My name is Natalie Bielfor. I'm the Digital Curation Archivist at the University of Manitoba Libraries. I would like to start off by acknowledging that the space where I work and live is located on Treaty 1 territory, the original lands of the Anishinaabe, Cree, Anisininuu, Dakota, and Dene peoples, and on the homeland of the Métis Nation. Because we're talking about digital data today, I think it's also important to acknowledge that digital information is a very material thing that relies on natural resources such as water, which in Winnipeg comes from Shoal Lake 40 First Nation on Treaty 3 territory. It requires electricity, a large portion of which comes from the Nelson River on Treaty 5. It requires resources mined from the earth, space to house servers from all over the world and often from marginalized communities, which I think is important to recognize when we rely on digital technology records so much in our daily lives. So today we're going to talk about what a data loss disaster can look like, where data loss can happen, and how to prevent it. Data is a bit of a vague term, so this session will mostly apply to digital records that you create as part of your research, though a lot of it can also be applied to digital records you create or maintain as part of your work at the U of M or any other digital records that you keep and you want to avoid losing in some sort of data loss event. So what does a data loss disaster look like? When we think about disaster, sometimes we think large scale, we think of tornadoes, fires, floods. And that can certainly happen. Fires, floods, storms can impact server rooms that hold your data. They can destroy your storage devices, your computers, etc. In more recent years, we might think of a large cybersecurity breach as another kind of digital disaster, things like malware, ransomware attacks. But disasters also don't have to be large-scale events. When it comes to data loss disaster, it can be a technical failure, like your computer powering off or suddenly freezing up in some way. It could be human error, accidental deletions, forgetting to save something, forgetting where you've saved something, forgetting the password you need to access it. Disasters can also be as simple as spilling a cup of coffee over your computer, your hard drives, your USBs, or dropping your USB somewhere on the way home on the bus in a parking lot. Even small actions can feel like disasters depending on the amount of data that you've lost in the process. Whatever the cause of it, it can have some pretty serious consequences. It can mean valuable data is lost to present and future users and researchers. Even once a research project is done, others can still ask new questions of old data. But it relies on researchers making their data available to others and ensuring that that data can continue to be accessed once they've moved on from the project. It can also mean that you lose unique data that cannot be recreated, and you find yourself in a situation with very limited, less than ideal options. You don't want to be in a situation like a researcher from the University of Windsor where you have to come up with a financial incentive to try and get your data back. And coming up with a data loss prevention plan is a good way to mitigate risks like that. The easiest way to prevent data loss is to think through where it can happen. So for paper-based records, data loss is a very visual process. If the paper is legible, the data is lost. The ink has faded, the paper is degraded or torn up. It's a very visible sign of data loss. In digital records, there are a lot more things at play, and they're not always as visible. With digital, whether you can read information on a page relies on a lot of different components working together and effectively. All the bits that make up your files need to be intact. You need the right software to make sure that you can open the file. You need a digital device like a computer or a tablet to read the file. If a file isn't stored on your computer or your tablet, and instead it's on something like a flash drive, you need something that can connect to and read that flash drive. Data loss can be caused by issues with any of those pieces that are required to look at your records. So to effectively protect your digital records from data loss, you have to think about all of those pieces. So you want to think about the files. If you're working with images or audio files, data loss can happen through compressions, depending on the formats you choose and whether they're lossless or lossy. Many file formats compress data to minimize the amount of space it takes up on your systems. While you do lose data in that process, it isn't necessarily a bad form of data loss. It really depends on your specific use case, but it's good to be aware of it. Most of the time, that data lost is lost when you're using something called lossy formats. Those changes aren't visible to the human eye. They're there really to make the system more efficient. And so it's not a bad idea to rely on lossy formats if you're not intending to overly manipulate or move those files by zipping them and compressing them even further. They might be a better fit if you are intending to like move your files around to someone else so they're smaller, they can be attached more in emails and things like that. So again, you do lose data by relying on lossy formats, but they increase the efficiency of your systems. So it's a bit of a trade-off. Where you might want to consider a lossless format, like a TIFF image, for example, might be if you need to keep the files for much longer, like maybe 7 years or more, or you really want a high quality image that captures those kind of imperceptible details that might be lost in a JPEG. If you're opting for lossless formats, they will take up more space than their lossy counterparts. So just make sure that you have enough storage space to accommodate that as well. Building time in for quality assurance in your work when you're accessing different files can also be helpful to keep an eye on and prevent data loss. If you haven't opened a specific file in a while, or you've just made a copy of that file and you've moved it to another directory, or your file shuts down unexpectedly, just take a quick time to just look at things and figure out, like, has anything been lost? You know, did the file, when it shut down, did I lose the last things I added to the file? If I moved, 50 files to a new directory, are there 50 files in that new directory? Do things look the same since the last time I accessed the files, etc. Keeping copies of your files is another way to mitigate data loss. If you have other copies, you can restore an unaltered version of your files when data loss occurs. How many copies you keep really should be determined on a case-by-case basis, but you might have heard of 3-2-1 rule, so maintaining 3 copies of your data on 2 different types of storage devices and having one in a separate location. That is a good rule of thumb. If 2 copies exist in your office, maybe a cloud service is a good option to have your data stored in a separate location. With more instances of cyber attacks and malware and ransomware happening around the world, if you're working with a lot of unique data that needs to stay intact for a long time, or that would be incredibly difficult to recreate if you had some sort of data loss event. Some are also advocating more and more for the 4-3-2-1 rule as a more robust method. So that's 4 copies from 3 different points in time. So that allows you to have more points of recovery, and then stored on 2 different types of storage systems, with one being stored offsite. Keeping one of those copies offline might also be a good idea. It doesn't eliminate all data loss risks, but it will protect that offline copy from risks like ransomware or cyber attacks that rely on network connections. You might also consider having some backups in place, although you should be aware of a few things before going the backup route in terms of a data recovery method. So a backup essentially takes a snapshot of your entire digital environment at a given point in time, and it restores that entire snapshot. So it's not always the best data recovery strategy to rely on in cases where maybe you've lost one file, because to restore an early version of that file, you'd have to return to earlier versions of every other file in your backup, meaning that you might lose more data than you gain by doing that. If you deleted something accidentally and it happens to be the only thing you've worked on since your last backup, then restoring a backup might be, worth it in that case. It really depends on the extent of your data loss and what has happened in between the last backup and the data loss event. So to assess how many copies or backups you should keep, I would recommend also first just finding out whether your storage spaces already generate those things, those backups or those copies. You can find some of that out by looking at the library's Research Data Storage Finder, which lists multiple storage options for research data and provides information on backups and storage locations. If the storage spaces you're looking at aren't listed there, or you want more information about data loss prevention mechanisms applied within those systems, you could also reach out to IST to ask as well. And that might help you determine that you already have a 3-2-1 rule in place, or just by having your files in UM's OneDrive or a SharePoint site. Ensuring your files comply with FAIR principles is another way to prevent data loss. FAIR principles help ensure that your data remains findable, either to you or to others, depending on whether you intend to make your data more widely accessible or you're working as part of a team. Ensuring your content is well described, clearly named, properly organized can all help you keep your data findable. Your data should also be accessible as part of the FAIR principles. Once you find it, someone else can find it as well. They can access it. If it's not intended to be made publicly accessible, does it tell people at least how they might access it if there are authorizations that can be requested where applicable? Your data should also be interoperable. So someone should be able to open your files, whether they are working on a Mac or a Windows operating system. They shouldn't require uncommonly used or expensive software to open up the file or to analyze it. It should function and be renderable in different environments without requiring too much effort on the user. And then finally, your data should be reusable as part of the FAIR principles. It should have terms of use or licenses so that people know they can reuse it. They should be able to understand its context to properly reuse it. If data isn't fair, it's not properly described or organized or contextualized and renderable. That is also a form of data loss. Maybe not necessarily for you when you're actively working on the content, but potentially for someone else or your future self when you might not remember the project as well, who might want to reuse that data and needs that context and that clarity to do that. Data loss can also occur because of issues with software as well. To reduce your software-related risks, it's good to use well-supported software. Well-supported software is useful to make sure that if you encounter a bug or an issue, you can get help from the software vendor or a wide community of users. Another important consideration is whether the software is commonly used. So things like Excel, PDFs, those are tools that everyone uses. So if Microsoft or Adobe one day decided to call it quits, they'd most likely have alternatives popping up to fill those gaps, given that there's a lot of people using them. If you're using some software that no one else uses and that stops being supported, you might find it difficult to find alternatives that will support those files if ever you needed it. It might not be that case if you're using open source software, meaning that the code is available to you. So whether or not it stops being supported, you still have that code to support the software. It can provide you with more control over the software, which does minimize the risk of data loss, but it's still something that I would say operate with caution. If you're looking at open source options, it can be a great option to ensure that you can have like that full accessibility with the code of the software that you need. But some open source software requires a lot of technical expertise to set up or maintain. It might not have a big community of people to offer software support if you need it. It might also not be frequently upgraded. So again, just consider how much support that software has before going that route. When upgrades are available for any software you're using, make sure that you're keeping up with them. Don't fall behind key updates. Keep the software you need to render your files up to date. Also keep the software that's meant to protect your files up to date, like your antivirus software. Upgrades to software in general are often meant to ensure that your software is updated to reflect current security threats, which helps minimize that risk of data loss again. It's also important to think about dependencies. Remember that software doesn't always run on its own. Some require other pieces of software. So for example, some software requires Java to be installed as well to run efficiently. And so it's not always just about keeping your software up to date when it comes to the software you're using to render a specific file, but also keeping any additional pieces of software that are needed to support that software up to date. Also think about the long term, where your data is going to live, what kind of moves it's going to make over its lifespan. It might start off as an Excel spreadsheet, but at different points in time, it could live in other software. It could go to other platforms or databases. And so thinking about like whether or not it can make those moves easily can be helpful. If you're compiling a single Excel workbook with multiple worksheets, for example, and you're intending to upload those worksheets into a database that requires it in a CSV format, CSV files only support one worksheet. So you could lose those other worksheets from your original Excel file in the process of converting your files to a CSV. So if you know that you'll need a CSV later on in your project before you start compiling the data, you can make sure to only have one sheet in each workbook when you start the project so that it makes that move to CSV a lot easier when you need it. Thinking ahead about those moves and how well your data can make those jumps is a good way to reduce the risk of data loss and reduce the amount of time you might have to spend recovering, reformatting, or cleaning up your data. And then lastly, in terms of thinking about what can kind of go wrong with your data, you need to think about the hardware level as well. So the things that you need to store your data. One method of data loss prevention for storage devices is to ensure that those devices are still supported and readable. So if you think about floppy disks and CD-ROMs, these are things that were once easy to read on a standard workstation, but now they don't come with those drives. Even flash drives, some Apple laptops no longer support standard USB ports, and you need a USB-C adapter to read the contents of a flash drive. So it's important to make sure that you can read the storage media, and if your computer doesn't support it anymore, make sure it's easy to find the adapter you need or start looking into moving data off of those pieces of storage media. Another way to prevent data loss is to properly store your storage devices. So things that might impact the longevity and quality of storage devices and the content on them includes the accumulation of dirt, dust, debris, scratches, corrosion, physical breakage of your storage devices, water damage. Some flash media like USBs can be corrupted by exposure to electromagnetism or shocks. Magnetic media like hard drives can be subject to mechanical failures, which can be brought on by shocks, shifts in temperature, if they're being stored in warmer temperatures, for example. You might recognize mechanical failures with hard drives when you hear some clicking noises when you connect your hard drive. It can almost sound like it's trying really hard or struggling to start up a bit. Storage devices also have a shelf life. So if you're keeping important records on a physical storage device, you might want to note when you've purchased it and kind of have a schedule to check on that device and move data to a new storage device to refresh it before it starts to degrade or perform less reliably. So yes, storage life expectancy for things like hard drives and USBs, that can vary pretty widely. Hard drives have a pretty wide range, anywhere between 3 to 7 years based on various sources. Flash drives, some say can last up to 10 years or more, but also sometimes less. It can really vary widely based on the make, the model, how you store the device. And it also doesn't prevent the files stored on those devices from degrading for some of the other reasons we discussed either. If you're utilizing cloud storage, you're not the person responsible for maintaining the storage itself. So in some ways that's useful, and that's kind of something off your plate. But there are still things to keep in mind if you're relying on cloud storage. It relies on an internet connection, so that puts it at risk of things like cybersecurity threats, basically 24/7. So you might want to maintain an offline copy if you're relying on cloud storage. It's also, because it's relying on the internet, means that it might not be the best solution if you're working in areas with poor connectivity. If you lose data even just temporarily because of networking issues, that can still create obstacles in your work. With cloud storage, you're also kind of at the mercy of the service provider, and you do lose some control over your data because of that. It can be, issues with supporting the ongoing cost because they can decide to increase it over time. It could also be that, one day they just decide they're not supporting a cloud storage service anymore, and depending on how they're shutting that down, maybe you don't have enough notice to get your data out. So there's still considerations around storage media when you're not managing the hardware. I also did quickly want to talk about just balancing risk mitigation strategies and environmental sustainability when we're talking about data loss prevention. We did talk today about making additional copies, refreshing your storage hardware every few years, making backups. Digital record keeping has a pretty hefty carbon footprint. The ways in which digital storage devices are constructed, how they're shipped, the energy they consume, those all take a toll on the environment. So I don't want the key takeaway today to be make a lot of copies, store a lot of backups, buy a lot of storage devices. Yes, those things can be important in data loss prevention, but don't implement these strategies just for the sake of it. Think about how many copies you need to feel more confident if a data loss event happens. Don't buy 10 external hard drives just in case you need them. Think about what you have and what you need in terms of storage space to accommodate that. In a similar vein, don't default to increasing your storage when you run out or you're running low. You can build time into your record creation process to declutter, organize, and clean up your files. Are there files that are taking up space when you haven't accessed or needed them in maybe 10 years? Maybe those don't need to be there anymore. Maybe you can clean out your downloads folder. So before putting in a request for more storage space or purchasing more storage, maybe just make sure that the things that are taking up your current space need to be there. Also think about how you dispose of your physical hardware as well. You can look at options to recycle your electronic storage devices. For university records, IST has confidential shredding and recycling services that you could look into. If they're not university records or they're not research data with specific disposition rules and they don't include any kind of sensitive or confidential information, the Office of Sustainability sometimes partners with different organizations and sets up a booth at the university center to collect storage devices to recycle. So that could be an option. Other practices that help promote a bit of digital sobriety includes powering off your devices when they're not in use, including when you wrap up your work for the day or you're away for an extended period of time. The Office of Sustainability does have a Green Office checklist that includes some guidelines about things that you can do to reduce the amount of energy your electronics use up. So that's also a useful resource to look at. So keeping what we've talked about so far in mind, to minimize the risk of data loss and be in a better position to recover your data if it happens, have a data loss strategy in place. Think about what we talked through today. Where can data loss happen, and use that information to think through how to prevent those issues and what you would do if you lost some of your data. Would you go locate another copy? If that's your plan, you can take steps now to make sure that you have that other copy when you need it. Establish clear and consistent practices. If you're keeping copies, maybe make sure that you update them on a regular basis. Set a reminder to check on those copies and make the copies on a regular basis to make sure that they're not showing signs of data loss or they're too out of date. Make sure that you store files consistently, you name them and you describe them so it's easy to know what they are. We talked about human error being one potential cause of data loss. That can be hard to completely mitigate, but you can integrate things into your practices to try and minimize those risks. Maybe schedule automatic backups if you're prone to forgetting that you need to make a backup. Maybe avoid bringing liquids near your computer, or bring a spill-proof mug or a glass, something with a lid, to avoid accidentally pouring liquids over your hard drives. Know your data, that's a useful thing to do, thinking about it holistically like we talked about. Always keep the files, the software, and the hardware in mind to better think through what could go wrong and how to minimize those risks. Knowing your data also means knowing what's important. Ideally, you'd never lose any data, but if you do, it can be helpful to have priorities in mind. That could help you decide where to focus your recovery efforts or whether a copy or a backup is the better option. For example, maybe restoring a backup means losing a bit of content from files that are less important, but also getting data back for your most important content in the state that you need it. So sometimes it's just knowing where your priorities are when it comes to recovering your data. Secure your data, so store it properly. Create a backup or a copy on a regular basis, or make sure someone is looking after those things for you. Again, if you're using a system, there's likely some mechanisms in place through IST already in place. Secure it through permissions as well. If you need to give access to others, think about what that access should look like. Do they need editing access, or is it maybe a read-only kind of situation? Minimizing the number of people who have editing access to your data means reducing the risk of human error. Less humans, less potential for error. Check in with your data. Don't just let it sit on a hard drive in your filing cabinet for 10 years. If you're working with research data, also consider depositing it. That makes it accessible in some ways. It's also another copy in another location. And it makes it reusable to others as well. Don't abandon your data also. Don't leave it on a drive that someone stumbles across years after you've retired. If you deposit it somewhere and you're the primary contact that someone needs to get in touch with to fully access the data, make sure that contact's kept up to date. If your email changes or you retire and you're not checking that email anymore, make sure there's a plan in place so that someone could still get access to the data when they need it. All of these things will help you minimize risks for data loss. And if something does go wrong, You can start by troubleshooting the issue. If you connect your hard drive to your computer and nothing happens, you can troubleshoot that. Maybe it's a small error that can be resolved just by disconnecting and reconnecting the drive or restarting your computer. If after troubleshooting, it seems like your data is lost, define the scope of that loss. Did you lose an hour of work or just a couple of files, or was it like a very big loss where you've lost everything or a week's worth of work? Was it all of your data, or just a specific piece? That can help you decide what your next step is. Ultimately, the next step is to restore your data, but how you do that depends on the scope of the loss. Maybe the next step is to restore a copy, or maybe it's to restore a backup. If you have a good disaster plan in place, you should be able to restore a copy or a backup when you need it. And that's a big benefit of digital data. If an important paper record is in your flooded basement office, you might have to jump into that water to try to rescue it. If all you have down there is your computer that is backed up on other systems in other locations, you don't need to jump into the water. You can walk away from the disaster, you can go get a coffee, wait for the all clear, and create a new copy from your other copies when things have dried up. Once you've restored the data, reassess. So did you get everything back? Does it look like you expect it to look? Are you missing still a bit of data, and what are you missing? And if you're struggling with your recovery options, you can also look for support from the university. So IST might be a good first step to help you out in a situation like that, to get, a backup or regenerate a copy and recover your data. You can also reach out to me as well if you're dealing with external storage media issues that, suffer a hardware failure. We do have digital forensics tools in the libraries that help us recover older digital archival records. And so we could look at whether some of those tools might help you to recover your data. The success of data recovery really depends on a case-by-case basis based on the condition of your storage media and the files that are on it, but it is still worth trying if you've exhausted all your other options. And that wraps up our session today. I've put a few links that might be helpful on the slide, including the Research Data Storage Finder, as well as a guide to self-preservation from the libraries that gives you some information on how to manage your data long-term. The Green Office checklist is there as well, the FAIR principles, and a link to IST's processes on decommissioning electronic devices. So if also my contact information is there if you have any more specific questions about something specific that you're working on.